Good evening all. Am I audible?
Yes, sir.
Yes, sir.
Okay, thank you. So in previous session we had discussed about the three different kinds of Z transforms, that is one-sided, right-sided, that is right-sided, left-sided and double-sided sequence, and example of each one of them: a power n u of n, b power minus b power n, u of minus n minus 1, then combined together. So we have discussed these transforms. After that, we have discussed the ROC properties. Correct? We have discussed the ROC properties. That is, there are 9 properties which we have listed. Is the screen visible to all? Let me know whether the screen is visible or not.
Yes, sir.
I'm waiting for your reply.
Yes, sir.
Okay, thank you. Now we have seen that these are the properties of ROC. First one, ROC cannot contain any poles. Poles are the values of Z for which Z transform will be infinite. So ROC will not contain any poles. Then for finite sequences, we have three properties: finite causal sequence, ROC entire Z plane except Z is equal to 0. If x of n is finite but non-causal, then ROC is entire Z plane except Z is equal to infinity. If it is a finite but double-sided sequence, then the ROC is entire Z plane except Z is equal to 0 and infinity. So between 0 and infinity, our ROC will lie. Then for a causal infinite sequence, ROC is right-sided, that is maximum, that is magnitude of Z is greater than R max. R max is the magnitude of the largest pole. Okay. Then x of n is non-causal infinite. Earlier causal infinite, the next property non-causal infinite length sequence. For that, magnitude of Z will be lesser than R minimum. R minimum is the smallest magnitude of any of the poles of x of Z. So there might be number of poles which leads x of Z to be infinite. Among them, the smallest value we need to choose, and lesser than that will be the ROC. Okay. And here ROC is interior to the circle. Earlier it is exterior to the circle with radius R minimum. There R maximum. If two-sided, ROC will lie between two circles, that is R1 will be minimum, R2 will be maximum. In between that, we have a ROC for the given x of n, that is when we find out x of z, for that ROC will be between R1 and R2. Then for a stable system, ROC contains the unit circle. And finally, we have the ninth property which says that ROC must be a connected region. So these are the properties. Any doubt regarding this? I hope there are no doubts regarding the properties, because already we have discussed the properties with examples also. Okay. Now properties of Z transform. Till now we have discussed about properties of ROC. Now let us begin with the properties of Z transform. Again, these are the very important properties what we have. Okay, let me explain here. So, properties of Z transforms. So first one is linearity property. So linearity property means what? Principle of superposition. It obeys Z transforms obey principle of superposition. That means if you are taking an input, say scaled version of input A x1n, you will produce an output of A1 x1 of Z. Okay, so for a system for Z transform, if you apply A1 into x1 of n, you apply for Z transformer. Z transform of this signal would be A1 x1 of Z. Similarly, if you take another signal, A2 and A1 are scaling factors, x2n, and you get the Z transform as A2 x2 of Z. Okay, now if we combine these to A1 x1 of n plus A2 x2 of n, and if we find out the Z transform, then we will get A1 x1 of Z plus B1 x2 of Z. Okay, this is the relation. If you take individual Z transforms and then you add A1, if I add, then I will get A1 x1Z plus A2 x2 Z. So individual Z transform we have taken and added, the result will be same as you combine both the signals x1 of n, x2 of n, scaled version, that is a1 multiplied with x1 of n, a2 multiplied with x2 of n. You might ask why a1 and a2 will take. It is not like always x1 is independent of 1, that is it is always behind x1, always 1 is not possible. It might be 3 by 4 x1. That's why this a1 is a scaling factor which we use, or a1, a2, any value. Okay, so this is linearity property. Let us go through that, how to solve it. Okay, here we need to have statement and proof, right? So statement is given, already I have told, if Z transform of x1 of n is x1 of Z with ROC lying between Rx1 minus to Rx1 plus. So this is the ROC. Say this is between some two values, say between 1 and 2. Z is lying between 1 and 2. That is what indication by Rx1 minus Rx1 plus. Okay. Similarly, x2 of n is there. Its Z transform is x2 of Z and its ROC is like this. Then Z of a1 x1 of n plus a2 x2 of n will be, that is if you take the Z transform of the scaled version of x1 and x2, it will lead us to a scaled version of individual Z transform summed together. Okay, and ROC being the intersection of above ROCs. Let me indicate that. ROC will be R x1 minus R x1 plus intersection R x2 minus R x2 plus. Okay, so this is the final ROC what we are going to get for the given signal for a linearity property. And how to prove it? This is the proof here. This is the proof. So let us consider our x of n is equal to a1 x1 of n plus a2 x2 of n. Okay, for this we need to find out the z transform. What is the equation of z transform? X of z is equal to summation n is equal to minus infinity to plus infinity x of n z power minus n. Okay, so what is x of n given? It is a1 x1 of n plus a2 x2 of n multiplied by z power minus n. Now n is equal to minus infinity to plus infinity a1 x1 of n multiplied by z minus 1 plus n is equal to minus infinity to plus infinity a2 x2 of n z power minus n. So this z power minus n I have multiplied into the brackets and simplified. So now we can write a1 and a2 are constant. I can take out the constants. A1 outside, then give me a second. Digital pen has taken some. Okay, a1, this is x1 into z to the power minus n plus summation n is equal to minus plus infinity. Sorry, a2 we should take out x2 of n z power minus n. So you know that what is this equation and what is this equation? What is this? A1 multiplied by, we are taking z transform of x1 of 1. We are taking z transform of x2 of n. So I can write this as x1 of z plus a2 x2 of z. So thus the linearity property is proved. Is that clear? Any doubts regarding this? ROC, as I have told, it is the intersection between ROC of the first term and the second term, that is the first signal x1 of n and x2 of n. Please let me know any doubts regarding this. Dhanit?
Sir.
Yes, are you able to understand?
Yes, sir.
Okay. So if you have any doubt, you can ask. Next, we have time shift or translation property. So, in time shifting property, this is second one. First one linearity, second one time shifting. our time translation property. Okay, here it states that if x of n will produce a z transform as x of z, then x of n minus n naught will produce z power minus n naught x of z. Okay, this is the time shifting property. And here the ROC for this one, if it is Rx z is greater than Rx minus and lesser than Rx plus, the same ROC will be retained. ROC will be same, but time shifted version of input signal will produce a Z transform multiplied by Z to the power the same amount of time shift n naught. Okay, so let us prove this property. Okay, this is the statement. Now let us move to the proof part of it. So we know that what is x of z? X of z is equal to n is equal to minus infinity to plus infinity x of n z power minus n. Correct? Now x of n is replaced by what? X of n is replaced by n minus n naught. Okay, so we'll write it as n is equal to minus infinity to plus infinity x of n minus n naught z power minus n. We are not replacing wherever n is there. We are not replacing that. We are delaying the input, not output. Okay, this we have studied in the linearity property. The time delaying property of the systems. Correct. Same property we are applying here. Now n minus n naught is there, right? Let m is equal to n minus n naught. Then what is n? N is equal to m plus n naught. Okay. So how we can represent this? And also here we have limits. N is equal to minus infinity to plus infinity. Correct. So n is equal to infinity means what happens to m? M is also infinity. If n is equal to minus infinity, m is also minus infinity, because if you substitute infinity here or minus infinity, the same value will be for m also. That's why we can change the limits easily, saying m minus infinity to plus infinity x of m, because I am replacing this n minus n naught by m, and z power minus n is there. So what is n? N is nothing but minus of m plus n naught. Okay. Now m is equal to minus infinity to plus infinity x of m z power minus m multiplied by z power minus n naught. So here m is equal to minus infinity to plus infinity x of m z power minus m. So this one is independent, correct? M variable is there, summation is for m, and this is n naught. So we can take it out as a constant outside. Okay. But what is this? This term. This term is nothing but x of z, correct? Any variable we can use, x of m, x of n. This equation will produce us x of z. That's why the answer what we get is equal to z to the power minus n naught multiplied by x of z, that is for x of n minus n naught. Z transform of Z transform of this x of n minus n naught is equal to Z multiplied by minus n naught into x of Z. Is that clear? Any doubt regarding this? Please let me know if you have any doubt. This is about time shifting property. Next one is multiplying by an exponential. So multiplying by an exponential will give us, say, let me give the statement. So this, according to this property, if x of n produces the z transform as x of z, then a power n x of n will produce an output x of z by a. Okay, this is the property. Multiplying by an exponential here. Okay, z tends to z by a. Same thing I have given. Okay, this is the property. And what about ROC? ROC is also reversed here. ROC is reversed. Instead of Rx minus 2 Rx plus, it will be multiplied by A into Rx minus 2 Rx plus. Okay, so this is the resultant ROC. Okay, so same is given here. So it will change ROC as well as the x of z. Z is divided by that factor, multiplication factor. Okay, let us see what is the proof of it. We know again we have to start proof with x of z itself. X of z is equal to, so this is our question. So the x of z equation, now multiplication by exponential, then what we get is n minus infinity plus infinity a power n x of n z minus, now n is equal to minus infinity plus infinity x of n a z inverse to the power n. Okay, this is x of z. Now let us replace n by minus m. Let n is equal to minus m. Then what we'll get? Summation, excuse me, sorry, here for this one directly we can solve. This is x of n z divided by a to the power minus n. If z a goes above, it will become a power minus 1. Minus 1 into minus 1 plus 1. So definitely we'll get that. So here what I'm doing is this a I'm bringing it to the denominator. So it will be, when it goes above, it will become a inverse. A inverse multiplied by minus n, that will become a only. Okay, a to the power n only. So that's why we can do a trick here and get the value as, okay, value as z by a minus 1. So we have x of z is equal to this one. X of z is equal to here. X of z is equal to this one. But here z is divided by a in the final equation what we got. That's why we can say this is x of z divided by a. Z transform value is divided by that equation. Z transform of an x of n is equal to x of z by a. So when we are given with any transform, say a n u of n, you have to find out what is the transform of u of n. After finding that, you have to divide that, wherever z is there, you have to replace it by z by a. So that is the meaning here. Okay, so this is the multiplication by an exponential property. Now we have the fourth property, that is ramp, multiplication by a ramp. You know the ramp signal, right? When n is equal to 0, output is 0. N is equal to 1, output is 1. N is equal to 2, output is 2. N is equal to 3, output is 3. Likewise, it will go in this order. That's why it is called the ramp signal. Okay, multiplication by this n, will lead us to the differentiation of the signal, Z transform. So let us try to understand what it is. If x of n will produce Z transform as x of z, then n into x of n. Earlier we had multiplied with a to the power n exponential. Now we are multiplying with a ramp. N value, if you taking time, multiplying with time, that is t into x of t was there, then also it is multiplication with ramp. So this will produce a z transform, which is equal to minus z d by dz of x of z. So multiplying by n is equivalent to getting x of z of given x of n, differentiating it and multiplying by minus z. Okay, so this is a property. Now let us move on to the proof. Here we need to first take input as n into x of n, and then we have to differentiate x of z is equal to summation n is equal to minus infinity to plus infinity, x of n z power minus n. This is our actual equation. Now x of n is multiplied by a ramp function. Okay. To prove this, let us differentiate with respect to z on both the sides. Differentiating with respect to z on both the sides. So what we'll get is d by dz of x of z is equal to let me consider this only. Given signal only we have to differentiate. I should not multiply directly given signal. I will have to differentiate this with respect to z. Then what we'll get is minus n x of n z power minus n minus 1. This is what the result we will get after differentiating the given signal, given equation, sorry. So here we will get minus n summation n is equal to minus infinity to plus infinity x of n z power minus n z power minus 1. So this is what we get. Now z power minus 1 is what? Minus of n by z. I can take it out. Okay. Now n is equal to minus infinity to plus infinity x of n z power minus 1. Okay. Z and minus sign, if we take on the other side, it will become minus z d of xz by dz equal to n is equal to minus infinity to plus infinity x of n z power minus n. That is multiplication of n. So multiplying x of n with factor n will lead us to this result. Okay, and that proves our property. Correct? Here z transform of n into x of n is nothing but minus z d by dz of x of z. So when we multiply any signal, this is our x of n sequence, any sequence by n, then how to find out z transform? Directly what you can do, we find the z transform of x of n given signal again ಮಾಡಬೇಕು, we have to find out the x of z. Then we have to differentiate it with respect to z. After that multiply it by minus z. That will give us the actual z transform of this function multiplied by n. Okay, ROC remains same here. That is our fourth property. Fifth property is convolution in time domain. This is the property. It is very important, whether it is for your communication subjects or digital signal processing subjects, again for control systems and all. Everywhere this property is valid. You do time domain convolution, it will result in frequency domain as a multiplication. Okay, so this is the property. Here you can see this is the property. X of n convolution y of n will give us x of z multiplied by y of z, and ROC is intersection of ROCs of first function x of n, second function y of n. Okay, we can take x of n and h of n also. They are just the function names. Okay, let us prove this property. Fifth one, convolution property. Any doubt? Let me know. I'm audible, right?
Yes, sir.
Yes, sir.
Okay. Now we have seen 4 properties. Going for the 5th property. Before that, I wanted to know if you have any difficulty in understanding the proof of any of the property. Please take that printout notes, okay, along with you, so that you can compare easily and get to know, and also write notes. Okay. Now convolution property. If you have x of n producing x of z as z transform, y of n, that is another signal, producing z transform as y of z. If you want convolution of x of n with y of n in time domain, that is z transform of x of n convolution y of n is equal to x of z multiplied by y of z. So sum of products whatever we are doing, now ಏನು ಮಾಡ್ತಾ ಇದೀವಿ, x of n y of n ಅಲ್ಲಿ we are producing sum of products in time domain, whereas in frequency domain it is just multiplication of the z transform of x with z transform of y. Okay, now let us go through the proof of it. Our equation x of z is equal to n is equal to minus infinity to plus infinity x of n z power minus n. But our x of n is now, our x of n is this one, convolution term. So let us write that x of n is equal to x of n convolution y of n z power minus n. Now you look at this equation. What is convolution equation? Let me know, anyone, what is convolution equation? X of n convolution y of n is equal to summation k is equal to minus infinity to plus infinity x of k y of n minus k into z power minus n. Correct? This is what we are going to do. Now n minus k is there. Let me replace this n minus k by m. Let n minus k equal to m. That means n is equal to m plus k. Correct? And we no need to change the limits. If n tends to infinity, m also tends to infinity. N tends to infinity, then m is also infinity. If n is equal to minus infinity, m is also minus infinity. Using this, we have to change. Actually, I said that we no need to change the limits. We can easily change the limits now. For this one, summation m is equal to minus infinity to plus infinity. K term will not change. We are replacing only m and n, sorry. X of k y of n minus k is replaced by m. Y of m. Now, interestingly, what we are going to do here is multiplying with, take this bracket. This was correct only. N is equal to m plus k. We have minus n here. So it is minus m minus k. Correct? N I have replaced with m plus k. So minus is multiplied minus m minus k. Now what we can rearrange and write is y minus infinity to plus infinity ym z power minus m summation k minus infinity to plus infinity xk z power minus k. Correct? So this order also I can interchange. Okay, I have written in the reverse order. I can change it as k is equal to minus infinity to plus infinity x of k z power minus k summation m is equal to minus infinity to plus infinity y of m z power minus m. So this is z transform of x, this is z transform of y. In between we have a multiplication, x of z multiplied by y of z. So the z transform of x of n convolution y of n will lead us to this value. Okay, so that is our convolution property. Is there any doubt regarding this? Proof is here. Okay, again ROC is the intersection of ROC of x of n and ROC of x of y. Sorry, y of n. Next we have is time reversal property. Sixth property we have is time reversal. If x of n will give us the z transform as x of z, then x of minus n would give x of 1 by z. This is the time reversal property. If we reverse the signal, say u of n was x of n. If this was the signal, you will get some x of z. Okay. Now if you want u of minus n, directly what you can do, wherever z is there, you replace it by 1 by z. You will get the z transform of this signal. Okay, that is the time reversal property. The proof of it. So if and then proof of it is, consider x of z first, n is equal to minus infinity plus infinity x of n z power minus n. This is our standard equation. Now if I change the or reverse the time, instead of n I am writing minus n z power minus n. Okay, so since I have changed this, let me represent minus n is equal to L, or if I say L is equal to minus n. Okay, so let me replace it. and let us see what happens. Summation will be when n is equal to minus infinity, L is equal to plus infinity, and n is equal to plus infinity, L is equal to minus infinity. That's why we get summation L is equal to plus infinity to minus infinity. So this is not going to make any changes, because my infinity in the minus infinity ಗೆ summation ಮಾಡಿದ್ರು ಅಷ್ಟೇ, minus infinity in the plus infinity ಮಾಡಿದ್ರು ಅಷ್ಟೇ. It will not change any answer or the result. Okay, now I can write this as x of L, whereas this one as z to the power plus L. Okay, z to the power plus L, minus n is replaced by what? L. X of L, z L. Okay, now in the next step we can rewrite this equation. This is L is equal to minus infinity to plus infinity. Limits na ನಾವು interchange ಮಾಡಿದ್ರೆ ಏನು change ಆಗಲ್ಲ. Okay, now let me write this as z power minus 1 power minus L. Correct? This is a possibility, right? So we can write like that. Then minus infinity to plus infinity, x of L 1 by z power minus L. So instead of we having x of n z power minus n, we are having x of L 1 by z minus L. So our z transform will be now x of 1 by z. So wherever z is there, we have to replace it by 1 by z. Let me write properly over here. This is x of z inverse, also I can write, or 1 by z. So it is changing time, reversing the time. Z transform of x of minus 1 minus n is nothing but x of 1 by z. First we have to find out x of z for the given x of n. Then wherever z term you get, you replace it by 1 by z. For example, for some x of n, I got z divided by z minus a as x of z. Okay, I have to now replace this, wherever z is there, I have to replace it by 1 by z. 1 by z divided by 1 by z minus a. This would be the answer if I want z transform of x of minus n. Okay, for given x of n, this will be the z transform. If you want the reverse, time reverse version of it, then you have to just reverse the z also, that is 1 by z. Okay, that will be our sixth property. Now seventh one is initial value theorem. It is I will explain it here itself, easier for you to understand. If x of n is causal sequence with z transform x of z, then x of 0 is limit z tends to infinity x of z. So here causal sequence means it is a right sided sequence, n greater than 0. Okay, for that initial value theorem states that you want to find out what was initial, or what is the value of x of z, x of n at 0 time, before starting of the process. Some process is happening. Before that, what was the initial value? Like if you are entering a room, okay, before entering the room, what was the condition of the room? Whether the light was turned on or off, whether fridge is on or off, or whether some window is open or not. So that is initial condition. Here also initial condition means what was the initial value before starting off some process. Okay, so to find out that initial value of the given signal, we have this property x of 0 that is for a given sequence we want to find out initial value x of 0 is nothing but limit z tends to infinity x of z. So we have to find out given signals z transform and then apply the limits z tends to infinity. Then we will get the initial value of the given sequence. Okay. So this is the standard equation. Let me solve it here only. What is given in the statement? For a causal sequence. For a causal sequence. Causal sequence means n is greater than 0. So definitely n is not minus infinity to plus infinity. So this we can change as n is equal to 0 to infinity x of n z power minus n. Okay. Now let me substitute n is equal to 0. So what we are left with n is equal to 1 to infinity. So this would be, if I substitute n is equal to 0, z to the power minus 0 will be 1. So it is x of 0 multiplied by 1 plus the summation what we get here is n is equal to 1 to infinity x of n z power minus. Okay. Now applying limit on both the sides. What we get is this value will become equal to 0. Why it will become 0? Because z to the power minus n I can write as 1 by z to the power n. Okay, x of n into this. So when I say z tends to infinity, 1 by infinity will be 0. So this term will become 0. That's why x of 0 will be equal to, in the reverse order here you can say, applying limit on both the sides, this value will become 0, whereas this value x of 0, it is independent of z, so it will remain. So we can rewrite this equation in the other order, that is x of 0 is nothing but limit z tends to infinity x of z. Okay, this is our initial value theorem. Similarly we have final value theorem, and go through this theorem. It is homework for you. In the next class I will explain this. Okay, then the difference in time property, this is also easier property, you can go through it. We will discuss this in the next class. Okay, let me know if you have any doubts regarding the properties what we have discussed. Harshita says, are you able to understand?
Yes, sir.
Okay, what is time reversal property? X of n is replaced by x of minus n. So what it will do to the z transform? Z is replaced by 1 by z. Is that correct? Yes, Vinayaka. Now attendance is also called in that way only. Vinayaka is not present. Darshanyam? No. Varun?
Present, sir.
Yes, are you able to understand these properties?
Yes, sir.
Okay, x of n minus n naught will give us Does that transform as time shift? Time shift will be giving x of z as what? Z to the power minus n naught multiplied by x of z. Correct? I'm
Yes,
asking.
sir.
Okay. Tulsi, are you able to understand?
Yes, sir.
Okay. If you have any doubts regarding the properties, all of you, those who are present, you can ask in the class also, or you can ask here now. Okay.